Hello, and welcome to this second module of 3D Modeling and Animation 1. This is the introduction to hard surface modeling. So today we're going to be making more complex shapes than the simple shapes using the Curves tool and Surfaces tools. So without further ado, let's get started. Okay, so the first thing you're going to want to do is activate the Curves tab on your toolbar in Maya. And then you're going to want to press spacebar and pick either a front or side view to create your curve. This is because the curve tends to snap to the grid, and we can make it in perspective view. It's just it'll snap to that floor space, and that's not what we want. So I'm going to press spacebar. I'm going to select the front view, press spacebar again. Even though I just used the EP curve tool, instead of using that or this pencil curve, which lets me just kind of sketch out a curve real fast, we want to be a little bit more direct. So instead of using those, I'm going to use the one on the end here. This is the Bezier curve tool. For those of you who have taken foundations in digital art, this will seem very familiar. It's just like the pen tool from Illustrator and Photoshop. So if we click once, it'll create corners. If we click, hold, and drag, it will create a tangent curve. Now here's the exception. If you click and hold and press any of the other buttons like Control or Alt or Shift, it will not make a broken tangent. It will like a Bezier corner. It doesn't do it that way. What it does is you make that curve and then you can double back. You can select the curves that you have created and press Control, and that will let you break the tangent and make that into a Bezier corner. I'm going to press Enter, and that's going to finalize my curve here. I can still modify the curve after the fact, though, by pressing the F9 key. That gets me back to my control vertices, or CVs, you'll hear me say over and over again. You can also right-click and hold, and that gets you the that gets you some options for the control vertex, for object mode, for hull, which lets you select sections. It's not very useful in this regard. But we can get to control vertex from there. But there's also something called curve point. We'll get into that one later. If I'm in object mode and I select Bezier curve, I can pick a point and continue to add on to this curve. I can also use move and rotate to modify the position of this curve. Scale doesn't really do much of anything, except you can scale the whole thing, or you could scale parts of it. But an individual CV, well, does a little bit. Also, if you press Shift and right-click, you can convert the CV into a corner, a Bezier, or a Bezier corner. You can move the angles that way. So you're not just limited to modifying it when you're in Bezier, when you're in the Bezier tool. When you're finished altering your curve, simply press F8 to get back into object mode. I'm going to delete this and make something a little bit more recognizable as a shape. It starts with Bezier. I'm going to press and hold the X key, and that's going to snap these first 2 points onto the grid here. And then I'm going to make a wine glass. Now I want you to note, as part of this, I am going to give the wine glass a thickness. And I'm snapping that last point onto the line there. Once we're done creating our curve, we're going to press spacebar, go back into perspective view, and then we're going to switch to surfaces, and we're going to create our 3D shape. Now note that I only made half of an outline, and that's because the revolve function is going to rotate this curve 360 degrees around its central axis. And so this back section, the other part will fill this in, leaving an empty space in the middle. You want that. You want your shapes to be to have nothing overlapping in the center. We'll talk more about good topology at a later time. Under surfaces, I'm going to click on revolve. And by default, the revolve is going to make a surface, which is also known as a NURB. So NURBS stands for non-uniform rational B-splines. This is a mathematic system for 3D modeling. Think of it as a three-dimensional vector graphic. It is mathematically perfect, but who cares? It's not generally usable in most 3D functions. I mean, they use it sometimes in movies. They use it all the time in things like prototyping and engineering. But for our purposes, we want this to be a polygon structure. So I'm going to double click on the revolve section, or I could go to surfaces, revolve option box. And that will open up the revolve options dialog box. Now, the first thing I want you to notice is that the output geometry is set to NURBS. We're going to switch that to polygons. And then when we scroll down, it will be set to standard fit. And when you hit apply, it's going to do a terrible job. So even now, it requires some additional settings to do a good job in creating a revolve. So just make sure your curve is selected. I'm going to show you two different methods for generating polygons using curves. One is if you really care about the structure and the roundness and smoothness of the object, and the other is if you don't care that much, but you still want it to be good. So there's an easy way and a hard way, is what I'm trying to say. First, we want to switch our type from triangles to quads. Next, we're going to do it the easy way. So we're going to set the tessellation method to count. So count, just you pick a target number. That's the number of polygons you want the shape to be made of. And then when you hit apply, it will try to hit that count as best that it can. If we go over to channel box and scroll down a little bit, under inputs, you'll see the revolve and you'll see the NURBS tessellation. And if we go to polycount, I'm going to highlight polycount, move into the perspective view, and press middle mouse button and drag it back and forth. And you can see the more polygons we add to that, I can even type something in, the smoother it gets. Easy. The only problem with doing it that way is that it has a tendency to treat the whole object as equalized, and you may want to have more horizontal or latitudinal lines than you want longitudinal lines or crossways. So it's like the roundness around versus the smoothness of the detail. For that level of control, we needed to do a general. But the problem is, as soon as you select general and hit apply, it's going to do a terrible job. That's because by default, the tessellation method in general is set to per surf number of isoparams in 3D. Anytime you see ISO in this regard, they're talking about isometric parameters. That's very technical jargon. We're going to ignore that. But what we can do is we can set these things to the correct settings. What we want is per span number of isoparams on both the U type and V type. What we're setting this to is the U number, and the V number essentially acts as a multiplier for the number of times it rotates around, which is set up here. We have a number of segments, which we currently have set to 8. Let's set that to 12, just to for demonstrative purposes. And then this U number will be a multiplier, so times 12, around the U and the V. The V, or vertical, will be the number of vertices that you have in your spline. So however many points you have between point A here and point B here, it'll multiply by 3. So let's see what that looks like. All right, with that done, we can go to the V number and we can increase it to smooth that shape out. So that gets you a much more personalized smoothness. One point remains. If you, I'm pressing 4 so that I can see my shape in wireframe mode. And then I'm going to select the Bezier curve and press F9 to get to the control vertices. You can still control the shape of your mesh that it is being generated by this curve by altering the curve. Another point to mention is that if you don't perfectly center the point on where the curve terminates, it will create holes in your topology. That was one of the reasons why I centered these vertices at the beginning and end of the curve when I created this. And again, I would just press the X button, and that lets you snap it to the grid. Once you're done, you can delete the curve, and that leaves you with just the 3D object. All right, why don't you give that a try and move on to the next lesson.